Zawala again, the Foundation for Equity and Excellence in Education in Liberia, FEW. Today, we're going to be going over yet another section of the West African Examination Council's Senior Secondary School Mathematics Examination for Liberian schools. We're going to be focusing on today's video on trigonometry, and we're going to be learning how we can find the sine and cosine and tangent of an angle, giving a point on the terminal side of the angle. So first of all, let's go over a few basic definitions. We want to talk about an angle being in standard position. We say an angle is in standard position when the vertex is at the origin. The vertex is at the origin. And the initial side is the positive half of the x-axis. So this is going to be the initial side. And then its terminal side is somewhere in the xy plane. So this angle here is said to be in standard position. The reference angle is the acute angle which the terminal side makes with the x-axis. So let's see something. So here's an angle here that is in standard position here. The same kind of angle we used before. Let me change this. Let me use the angle that we used in the last slide. So this is my angle theta in standard position. Now the reference angle for this angle will be the acute angle that this terminal sides make with the x-axis. So actually, this is my reference angle. I will call it beta. Beta is my reference angle. It's going to be an acute angle. That's the angle we call a reference angle. We can use the reference angle to be able to use our base angle of 30, 60, and 90, and some of the other ones to be able to, or even anything to be able to find the sine, cosine, and tangent of an angle. For example, so when an angle is located, when an angle is in standard position has its terminal side in quadrant 2, the reference angle will be here. How will you find the measure of the reference angle? Say if I call the reference angle beta. How do I find beta in this case? Beta here in this case would be basically 180 minus this angle what? A. So it's 180 minus A. So that's going to give you an acute angle. Now when an angle is in quadrant 1, the reference angle beta will be equal to A. It's the same as the angle. Now when an angle is in quadrant 3, how do I find the reference angle B? To find reference angle beta in this case, what I would do would be basically the angle A minus 180. See, A is slightly more than 180. So when you subtract 180 from A, you just get this small piece right here, which should be an acute angle. Now, all right, what about over here? So in the fourth quadrant, that was going to be basically the angle. The reference angle beta would be basically equal to 360 minus angle what? A. Simple. So that's how you can use to find the reference angle. Once you know the reference angle, you can construct a right triangle, use that right triangle to find the sine, cosine, tangent, or any of the trigonometric measures of their angles. Okay? One of the things you have to just take into consideration is the location of the angles and to be able to know whether their values will be negative, positive, or so. So again, I've already done that. We say for an angle in quadrant 1. So if I'm saying beta is the reference angle, we already talked about this. Beta will just be equal to A. If the angle is A. For an angle in quadrant 2, beta, our reference angle will be 180 minus A. For an angle in quadrant 3, beta, our reference angle will be A minus 180. And for an angle in quadrant 4, beta, our reference angle will be 360 minus A. Degrees, 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 degrees. Beta is in degrees. Good. So how do we find the sine, cosine, tangent given the point on its terminal side? So we sketch the angle in the xy plane. Then we'll find the length of any missing side using the Pythagorean theorem. We select the reference angle and we apply the appropriate trigonometric ratio. Let's see how it works. Let's do something here. Let's do our xy plane here like this. So we are dealing with an angle -5, -12. That means we go this way, say -5 here, and also -12. So it's going to be this way, -12. Say, for example, if here was -12, so this is going to be our point right here on the terminal side of this angle. So how then do we find this? How then do we find the cosine of this thing? So what we're going to do is that we're going to use the reference angle for this. So the reference angle, so here's our angle actually. This is the angle. But the reference angle would be the acute angle that this side, this terminal side, makes with the x-axis. So this is going to be our reference angle here. So how do we find a reference? How do we find anything here? So this side is -12. This piece is -5. So this is our alpha right here. Let's call that. We can just say alpha in this case. So how do we find the value of the cosine of alpha here? I will use our beta. I'm using reference angle, so I'll use beta. So how do I find this? So I can say to find the cosine of my reference angle beta, I know cosine by rule is equal to what? Adjacent over hypotenuse. Now, but over here, I don't have my hypotenuse. I have the adjacent, and I have the opposite. So I'm going to use Pythagorean theorem. So this is the hypotenuse. That's the, I don't know. So I'm going to do -5 squared plus -12 squared. That should give me c squared. This is going to be 25 plus 144. That's going to be c squared. When I add it, I'm going to have 169 is equal to c squared. Take the square root, take the square root. I have c is equal to 13. So this side is going to be 13. So our hypotenuse is going to be 13. So now to find my cosine, I must use what? Opposite. I'm going to use adjacent, which is what? I'm going to use adjacent over hypotenuse. What's the adjacent of the angle? It's -5 over the hypotenuse, which is what? 13. So this is going to be basically my cosine alpha. Since it is in quadrant 3, the cosine is negative, I have that. If beta is an angle in standard position with this terminal side to this, so this angle beta is in standard position with this terminal side, this. So let's see, negative. So let's say this is -5, and this is going to be, say, 12. So this is going to be the terminal side right here. So the angle is in standard position will be this angle. So to actually find the sine, in this problem we need to find sine and cosine of beta. To do that, we're going to use this reference angle over here. So I'm going to be using this angle here. I can even call it alpha. Doesn't matter. I will use that to find the sine, cosine of beta. Now, so how do I find the sine of this angle? The sine of this angle alpha, which is going to be the same as the sine of beta when we take into consideration the sine. So I'm going to say sine of beta will be equal to the opposite. This is going to be 12. Will be equal to the opposite to this angle, which is 12. And again, we've done this already. So we know if we don't do this, if we did -5 squared plus 12 squared to give us c squared, it's going to give me -5 squared is 25 plus 144 is going to give me c squared. I'm going to have 169 equals to c squared. Take the square root, I'm going to have this side to be 13. So that's going to be, sine is going to be 12 over what? 13. Understand, this angle is in quadrant 2, so the sine must be positive. It's up. Now, then, to find the cosine, we can clearly see here that the cosine of beta would be equal to the adjacent, which is -5, over the hypotenuse, which is 13. So the cosine of beta is over sine beta minus cosine of beta. Now, what we know here is that from our earlier computation, we found that sine of beta was equal to what? 12 over what? 13. And the cosine of beta was equal to -5 over 13. So we're going to substitute those things in here. Sine of beta will be 12 over what? 13 plus -5 over what? 13 over sine of beta again is what? 12 over what? 13 minus cosine of beta is negative 5 over what? 13. So let's do some things. Have the same denominator. So to find the numerator, you do 12 minus 5. That's going to be 7 over 13. Now, this is going to be negative, negative. So it's going to be plus, plus. Same denominator. So denominator is going to be the same. Add the numerator. 12 plus 5 is 17. So basically what we have here is 7 over 13 divided by 17 over 13, which switches into multiplication. But the reciprocal of 13 over what? 17. That's going to cancel. That's going to cancel. And our answer will just be 7 over what? 17. Again, thank you very much. This has been a production of FUEL, the Foundation for Equity and Excellence in Education in Liberia. We continue to provide quality content, educational videos to help Liberian students improve their learning opportunities. We are committed to this, and follow us on YouTube, follow us on Twitter, like us on Facebook, subscribe to our YouTube channel, and don't forget, we appreciate every contribution, every donation. We are committed to improving the quality of our product. Your contribution will help to make our product better. Thank you very much.